All right, so in this video, we're going to talk about Charles' law. All right, so Charles' law basically talks about the relationship between volume and the temperature of a gas. So the volume of a gas is directly proportional to its Kelvin temperature at constant N, or the amount of moles, amount of substance, right? The number of moles substance won't change, and its pressure. So what does this mean? So if you, let me just kind of illustrate this. So let's just say you have a container, right? Closed container. Here's the lid, right? And so we apply about 1 atm, okay? And we see that the volume here is about 0.5 liters. Now the temperature in this case is about 200 Kelvin, okay? Now let's just say we go ahead and heat it up, okay? Now when we heat it up, we do our best to make sure that the pressure being exerted remains the same. So we do not change the pressure, but then we notice that the volume increases by half, right? Not increases by half, but it doubles. It's because that the temperature of the substance has also doubled. So it went from being about 200 Kelvin to 400 Kelvin. All right. So remember, it's a direct proportionality. So that means if you increase one, the other one's going to increase by the same factor. So if you double the Kelvin temperature, then you're going to double the volume. If you triple the Kelvin temperature, then you're going to triple the volume. If you have to double the Kelvin temperature, then you will have the volume. All right. And so mathematically speaking, the way that we look at Charles' law is that V1 divided by T1 is equal to V2 divided by T2. Okay. Now the thing that's really important is that the temperature must be in Kelvin. All right. And reason to this is because Kelvin, the unit itself doesn't become negative, or it can't become zero. That's actually the more correct answer. The unit itself cannot become zero. At that point, we're at absolute zero, the coldest that any substance could be, at least in this universe. All right. And so, which at that point, then everything becomes undefined, right? The laws of physics of what we understand just kind of goes haywire at that point. But anyways, this is the reason why temperature must be in Kelvin. All right. And so let's look at an example of this, of using this equation. All right. So let's say we have an average adult and they inhale a volume of 0.50 liters of air within each breath. All right. Now, if the air is warmed from the room temperature, which is roughly 293 Kelvin, to the body temperature, so this is room temperature, okay, to the body temperature, which is roughly 310 Kelvin, so body temp, while in the lungs, what is the volume of the air that's being exhaled? All right, so this is the volume of air inhaled, and so what I want to know is the amount of air that's being exhaled. All right, so in a sense here, this is V1 T1, all right, T2 V2, all right, and so what we're solving for is V2. So if this is our main equation here, let's go ahead and just rearrange this so that way we could go ahead and figure out what V2 is. So when you rearrange this, you get that T2 times V1 divided by T1 is equal to V2, because we're solving for V2 essentially. All right. And then we plug in the numbers accordingly. All right. And so the numbers that we're going to put in. All right. So we have V1 here, T1's here, T2's here. All right. So T2, which is 310, all right, times the 0.5 divided by 293. All right, and so if you put this in a calculator, we get that the answer is 0.53 liters. So that's the volume of gas that you're going to exhale out in this situation. All right, so that's Charles' law.